we are back with more integrals, and we are given a hint, which I have not written down, and that is to use a substitution. Now, if we use a substitution, it only makes sense if, let's say we choose a u, and it only makes sense if the derivative of u shows up in the original expression. If I, for example, take u to be x, the derivative of u is 1. Okay, I mean 1 is there, so we'll just get ln of u over u, but that's probably not that productive. Maybe we'll try another thing. Maybe I'll try 1 over x. So the derivative of 1 over x is what? It's minus 1 over x squared dx. But this doesn't show up here, does it? Yeah, it doesn't. Then maybe I should look at the derivative of ln of x. What's the derivative of ln of x? You know, it's the last function you can take the derivative of. And we know that we're looking for a u sub, because that is what the hint gave us. And we know that this should work, then probably the derivative should show up in the expression, and it should not be a 1. Then probably it will be 1 over x. But that is just your confirmation bias kicking in. The derivative of ln of x is just 1 over x. I'm just saying how you would figure out the derivative without knowing that the derivative is the derivative, just from the info that I'm feeding you. But anyway, that's just some fun. Use this fun. But it is good. So now I just need to isolate my du, my dx. So dx is x times du. And then everything's perfect. Life's amazing. You know? You get an integral from x is equal to 1 to x is equal to e. Remember that the boundaries are always with respect to the variable we're integrating with. Instead of ln of x, I write u. I will also write 1 over x, because that's fine. And instead of dx, I'll write x times du. Then this is why we choose the derivative which appears in the expression, because it will always cancel out. Then this gives us an integral from x is equal to 1 to x is equal to e of u du. So you can do one of two things. You can either integrate this, see what it gives you, then plug x back in, or you could just very simply make this into u, but then you would ask yourself, if x is equal to e, then what would u be equal to? It will be equal to ln of e. And if x is equal to 1, then u will be equal to ln of 1. Now this should be interesting, and because we will be able to simplify it in a moment. Now the integral of u, it's u squared over 2, right? If you take the derivative of this, you get u. So that's why. And you plug in from u is equal to ln of e to u is equal to ln of 1. But guess what? ln of e is just 1, and ln of 1 is just 0. The reason for this, so by definition, if ln of e is equal to a number, let's say a number n, then we're saying basically that, well, ln of e first off is the log base e of e. So this is equivalent to saying that e to the power of n is equal to e. So e to the power of n is equal to e to the power of 1, then probably 1 is equal to n. So that is why it works. More generally, the definition goes as follows. So the log base b of k is equal to n is equivalent to saying that b to the n is equal to k. So I have a good exercise for you. Can you check that ln of 1 will give you 0? So you can check this. It should be nice. I mean, you'll just get, so log, so an ln is a log base with base e, and then it's what? It's it's ln of 1, so it's log base e of 1 is equal to some number. We still need to find out. So e to the power of, so we're saying that e to the power of n is equal to 1. And the only n that gives you this is n is equal to 0. So that is why ln of 1 is 0, if that makes sense to you. So I'm just using the definition. You don't need to do this in the exam, you just write this down. But I'm just writing it for you if you've never seen it before. Then it is very simple. One time I plug in 1, so I get 1 squared divided by 2, and then I take away 0 squared divided by 2. This is of course 0, and in the end I just get a half as my answer to the exercise. So the trick here is to always use, or maybe I should say only use substitution when there is a function whose derivative is in the expression. Now we are lucky here with ln of x, its derivative is 1 over x and it's there in the integral. So we can proceed like this. And when we proceed like this, we're able to cancel out this x. We get a simpler integral, u squared over 2, from 0 to 1, 1 over 2, 1 over 2. So just check this, make sure it's correct. It is, so I don't have to repeat this recording. I guess I'll see you in the next one.